What is biomedical research design? Definition and purpose: biomedical research design is like the blueprint for scientific exploration in the medical field. It provides a structured method for evaluating theories, testing hypotheses, and drawing significant conclusions about human health and diseases. Essentially, it's all about planning what you want to explore, figuring out how to get there, and making sure your findings are solid. This careful planning process starts with defining a clear research question. Imagine you are curious about whether a new medicine helps lower blood pressure better than an existing one. Your design needs to decide how you will test this. What kind of study will you conduct? Will it be a clinical trial, an observational study, or perhaps a combination? Setting the purpose is crucial. It guides the entire research journey, ensuring that every step you take is focused on uncovering meaningful insights. The ultimate aim is to provide evidence that can lead to medical advancements, improved healthcare practices, and better patient outcomes. For anyone stepping into the world of biomedical research, understanding the design is your first step towards impactful discoveries. How it shapes research outcomes: a well-thought-out research design significantly influences the outcomes of biomedical studies. Think of it as the sturdy foundation of a house. If the foundation is unstable, anything built on top is at risk. Similarly, without a robust design, research findings might be unreliable or even misleading. One vital aspect is how you select and manage your participants. A random and diverse selection enhances the reliability of your results. It's also important to determine how data will be gathered. Will you use questionnaires, laboratory tests, or technological gadgets to collect data points? Crafting these processes clearly ensures you can answer your research question convincingly. Moreover, the design impacts how you handle unexpected challenges. Changes in circumstances, data inconsistencies, or surprising results need to be managed carefully. A flexible yet focused design aids in navigating these twists professionally. In summary, a solid design doesn't just answer a question, it opens doors to new questions, fueling further research and breakthroughs. So, when diving into biomedical research, think of the design as your compass guiding you toward valuable, actionable insights in the vast world of medicine. Types of biomedical research designs: experimental designs. Hey there! Experimental designs in biomedical research are like setting up a lab experiment. These designs allow scientists to control certain variables to see how they affect something else. Think of it as a science project where researchers can tweak one thing, like a new drug, to see if it makes people healthier. The classic example here is the randomized controlled trial, RCT. RCTs randomly assign participants to either the treatment group, which receives the intervention, or the control group, which does not. This setup helps ensure that the results are due to the treatment itself, not other factors. It's like baking cookies and changing just one ingredient to see what makes them the tastiest. Observational designs. Now, observational designs are a bit different. Imagine you're a detective recording what you see without interfering. That's what researchers do here. They observe and record data without trying to manipulate any variables. These designs are useful when it wouldn't be ethical or practical to carry out an experiment. For instance, you wouldn't ask people to start smoking just to see how it affects health. Instead, researchers might follow people who already smoke to study the effects. There are a couple of common types: cohort studies, which follow a group of people over time, and case control studies, which compare people with a condition to those without. Observational designs help uncover trends and correlations. Translational research approaches. Let's talk about translational research approaches. These are all about taking discoveries from the lab and using them to improve public health. It's like finding a cool new tool in your science kit and figuring out how it can help in real life. Translational research breaks down barriers between lab work and clinical application. It often involves a team effort, with scientists, clinicians, and even patients working together. The goal? to get effective treatments to patients as quickly and safely as possible. This approach underscores the importance of bridging the gap between theoretical research and practical solutions, ensuring that breakthroughs benefit everyone. The importance of research design in biomedical studies. When diving into the world of biomedical studies, having a strong research design is crucial. Think of it as the blueprint that guides everything. A good design ensures the study is valid and reliable. Let's explore why this is so important. Ensuring validity and reliability. First up is validity and reliability. When we talk about validity, we mean how well a study measures what it's supposed to measure. Imagine you're testing a new medicine. If your study says it improves health, we want to be sure that it really does. That's validity, making sure our conclusions are on point. Reliability, on the other hand, is about consistency. It's asking, if someone else did the same study, would they get the same results? We need a study to be reliable so that its findings aren't just a one-time fluke. To achieve this, researchers often use standardized procedures. They follow specific steps and methods to minimize variations in the results. It's like following a recipe. Small changes can lead to different outcomes. Consistency is key for building trust in the results. Avoiding research bias. Next, let's chat about avoiding research bias. Bias can sneak in when researchers let personal beliefs or expectations skew the results. Imagine if you're really excited about a new treatment and you unintentionally focus only on data that supports your theory. This would give an incomplete picture. To tackle this, researchers use blinding and randomization. Blinding means the participants or even the researchers don't know which treatment a subject receives. It's like a guessing game, keeping everyone fair and square. On the other hand, randomization assigns subjects randomly to different groups, preventing any favoritism. A thoughtful research design helps control these bias elements, ensuring the results are credible. This credibility means that other researchers and clinicians can make informed decisions about future treatments. In the end, a well-structured study paves the way for discoveries. It's how we build on knowledge and progress in medicine. So, when planning a study, paying attention to design isn't just wise, it's essential. Common challenges in biomedical research design. Ethical considerations. When diving into biomedical research, ethics come front and center. Researchers must navigate a complex web of ethical guidelines to ensure their work respects the rights and dignity of participants. Imagine you're exploring a new medical treatment. It's crucial to get informed consent from participants, meaning they fully understand the risks and benefits. Moreover, there's a need to balance potential scientific gains with the well-being of subjects, ensuring no harm comes to them during the research. The challenge is about maintaining high ethical standards while still pushing the boundaries of what's possible in science. Technical limitations. Now let's talk about the technical side of things. Biomedical research often involves cutting-edge technology that's expensive and complex. For instance, sophisticated imaging devices, like MRI machines, require skilled operators and constant maintenance. This technical hurdle means not every research facility will have access to the latest tools, possibly limiting the scope and accuracy of their studies. Resources are finite, and researchers must often make do with what they have. This can lead to compromises and potentially affect the results of the study. Data collection hurdles. Finally, collecting data in biomedical research isn't just about gathering numbers, it's a meticulous process that demands precision and patience. There are various factors at play: ensuring sample sizes are large enough to be statistically significant, controlling for external variables that might skew results, and handling sensitive patient information with the utmost care. Data accuracy is crucial because even a small error can significantly alter research findings. Researchers face the constant challenge of maintaining data integrity while dealing with real-world constraints like time and budget pressures. These challenges are part of what makes biomedical research such a demanding yet rewarding field. By raising awareness of these issues, Budding researchers can prepare themselves better for the complexities they might face. Balancing ethical practices with technical and data challenges is no small feat, but it's essential for advancing medical knowledge and improving patient care. Steps to crafting an effective research design. Creating a good research design is like drawing a map for a treasure hunt. It's all about knowing where you're going and what you need to get there. Let's dive into the steps to make your research journey smooth and successful. Identifying research questions. First off, you need to figure out what questions your research will answer. This step is super important because it sets the direction for everything that follows. Think about what sparks your curiosity. What do you want to discover or prove? Your questions should be specific and clear. Avoid broad questions that could take you in too many directions. A well-defined research question will keep your study focused and manageable. Choosing the right methodology. Once you've nailed down your research questions, it's time to pick the best way to find your answers. This is where choosing the right methodology comes in. Are you going to conduct experiments, surveys, or maybe observational studies? Each method has its pros and cons, depending on what you're trying to achieve. For instance, experiments are great for testing hypotheses in controlled settings, while surveys can help gather lots of data from a wide range of people. Think about your research goal and pick the method that best fits your needs. Gathering resources and tools. You now know your questions and how you'll answer them, so it's time to gather the resources and tools you'll need. This could include things like lab equipment, software, or access to certain databases. Don't forget about the human resources you'll need too, like mentors or colleagues to bounce ideas off or who can provide feedback. Also, think about your budget and timeline. Make a list of everything you need and start gathering those resources early on. Having the right tools at your disposal can make a huge difference in how smoothly your research goes. Remember, good planning can save you a lot of headaches down the road. Happy researching! Tools and technologies in research design. Software for data analysis. Let's dive right into how software helps researchers make sense of all that data they gather. Picture this: mountains of numbers and figures, all waiting to tell a story. That's where data analysis software comes in handy. Tools like SPSS, SAS, and R are common choices. They help researchers run complex statistical tests without breaking a sweat. With these programs, you can plot graphs, identify patterns, and draw meaningful conclusions. It's like having a virtual assistant that ensures your results are both accurate and reliable. Innovative imaging techniques. Now, onto something really cool: imaging techniques. These are the gadgets and technologies that give us a glimpse inside the body without making a single cut. Sounds like magic, right? Techniques like MRI, CT scans, and PET scans have revolutionized the way we see and understand the body's inner workings. They provide high-resolution images that help in diagnosing diseases, monitoring treatments, and conducting detailed research studies. Plus, newer innovations like functional MRI, fMRI, allow researchers to even see real-time brain activities. It's like having X-ray vision but way more sophisticated and precise. Genomic and bioinformatics tools. Lastly, let's talk about the mind-blowing realm of genomics and bioinformatics. Think of genomics as the study of all our genes. It's the roadmap of life. Modern genomic tools like CRISPR allow scientists to edit genes, which opens up possibilities we never thought possible, like fixing genetic disorders. And then there's bioinformatics, a field where biology meets technology. Bioinformatics tools help manage and analyze genetic data. Imagine trying to understand the vast amount of information our DNA holds. That's like sorting through an endless library of books. Bioinformatics simplifies this by organizing and interpreting all that data, making it easier to discover links between genes and diseases, paving the way for personalized medicine. These tools and technologies are the backbone of cutting-edge research. They're not just gadgets, They're game changers that empower researchers to explore, understand, and innovate in the world of biomedical science. Ethical considerations in biomedical research. Informed consent. Hey there, let's imagine you're all set for an adventure. You're curious but a little unsure about what's going to happen next. In the world of biomedical research, participants often feel this way, which is why informed consent is so important. This process ensures that everyone involved understands the purpose, procedures, risks, and benefits before they sign up for a study. Think of it as a detailed map given before a journey, outlining all possible paths and what might be encountered along the way. It's crucial because it respects the autonomy of the participants, empowering them to make decisions based on clear, accurate information about the study. Patient privacy. Now, picture keeping a secret, something that's important and personal. In biomedical research, patient privacy is like safeguarding that secret. Researchers must handle all participants' data with utmost care, ensuring it's secure and confidential. This means storing information safely and sharing it only with individuals who have permission. Imagine having a special lock on a diary. Only those with the key can peek inside. This protection is vital to maintain trust, as no one wants their private information shared without consent, right? By upholding privacy, researchers show respect for participants and their personal lives. Clinical trial regulations. Finally, let's dive into some rules of the game, the clinical trial regulations. Just like in sports, rules ensure fairness and safety. In research, these regulations set the groundwork for conducting studies ethically and safely. They cover everything from how trials are planned and carried out to how results are reported. Think of it as a guideline book that helps researchers ensure participant safety while aiming for reliable results. Without these rules, studies might become chaotic or even harmful, which nobody wants. So, these regulations are crucial in maintaining the integrity and credibility of biomedical research. Through informed consent, patient privacy, and clinical trial regulations, we ensure that everyone involved is respected and protected. This way, biomedical research can continue to advance health knowledge while keeping ethics at its core. Data management and analysis. Keeping your data organized and ready for analysis is a crucial step in biomedical research. This process ensures that all collected information is both reliable and accessible for future use. Let's dive into some of the key aspects of data management and analysis. Data collection techniques. Getting accurate data starts with choosing the right data collection techniques. In biomedical research, you often collect data through several methods: surveys and questionnaires. These are handy tools when you want to gather information on patient histories or health behaviors. They can be distributed online or in person. Clinical trials. Trials are fundamental for testing the effects of new treatments or medications. They require careful planning to collect precise and consistent data. Observational studies. In these studies, researchers observe subjects without changing any variables. This method is useful for seeing how factors naturally affect health outcomes. Lab experiments. Conducting experiments in a controlled environment allows for collecting data under specific conditions, which helps in understanding detailed biological processes. Deciding on which technique to use depends on your research objectives and the type of data you need. Each method has its pros and cons, so consider what aligns best with your study goals. Analysis software options. Once you've got your data, how you analyze it can make all the difference. Picking the right software helps in drawing meaningful conclusions. Here are some popular analysis tools in biomedical research. SPSS, Statistical Package for the Social Sciences. This is a favorite among researchers for its user-friendly interface and robust statistical analysis capabilities. R. Known for its flexibility and open-source nature, R is a powerful tool for statistical computing and graphics. It's ideal for complex data analysis. SAS, Statistical Analysis System, great for handling large sets of data. SAS offers comprehensive tools for advanced analytics. Python. Highly regarded for its versatility, Python is used globally for data analysis, owing to its extensive libraries like Pandas and NumPy. Choosing the right software depends on your comfort level, the complexity of your data, and your analysis requirements. Take time to explore these options to make the best choice for your research. Interdisciplinary approaches in biomedical research. Collaborations with engineering. Biomedical research often thrives when it breaks down silos and crosses paths with other fields. A great example of this is teaming up with engineers. When biomedicine meets engineering, magic happens. Engineers bring technical know-how, which can lead to designing cutting-edge medical devices or developing innovative treatment methods. Think about the development of prosthetics or robotic surgery tools. These are all products of engineers and biomedical researchers joining forces. During such collaborations, engineers often provide systems to test new biomedical theories. This practical insight can push theoretical research into real-world applications faster. For instance, the introduction of 3D printing in creating custom implants is a testament to these combined efforts. It helps create solutions that are not just technically sound but also cost-effective and tailored to patient needs. Integrating clinical practices. But it's not just engineering that's making waves in biomedical research. Bringing in clinical practices is like having a reality check for any new ideas. When clinical experts get involved, they ensure that research stays grounded and aligned with patient care. For medical research to truly benefit people's health, it cannot exist in a vacuum. Doctors and nurses offer invaluable perspectives on how a new drug or technology would work in everyday healthcare settings. Integrating clinical experience into research helps in creating practical solutions that can be directly implemented in hospitals and clinics. For example, in developing new drugs, clinical trials play a crucial role in determining if a treatment is safe and effective. Clinicians guide researchers on patient needs, helping to focus on what's most beneficial for patient outcomes. Ultimately, the cross-pollination between engineering, clinical practices, and biomedical research is essential in solving complex health issues. Students interested in these fields should embrace such collaborative opportunities to innovate and move forward. Bridging these disciplines not only speeds up discovery but also ensures that new technologies and treatments are both feasible and readily adaptable for real-world healthcare scenarios. Through teamwork across different specialties, biomedical research keeps advancing, leading to better health solutions for everyone. Trends in biomedical research. Design. Personalized medicine. Personalized medicine is changing how we think about healthcare. Instead of the one-size-fits-all approach, personalized medicine considers a person's unique genetic makeup, lifestyle, and environment. This trend in biomedical research design means treatments are more accurate and tailored to individual needs. Imagine going to the doctor and getting a treatment plan designed just for you. How cool is that? Researchers are using advanced tools to understand genetic data better, making it possible to predict diseases before they happen. What's more, it can help in determining the best drug and dosage for each patient, reducing side effects and improving outcomes. By focusing on individual differences, personalized medicine offers a more precise and effective healthcare approach, striving to improve every patient's quality of life. AI and machine learning applications. AI and machine learning, ML, are powerful tech tools that are fast becoming essential in biomedical research. They help in sorting through massive datasets. Think of them as super smart assistants. These technologies can recognize patterns humans might miss, leading to new insights and discoveries. For example, AI can analyze medical images or genetic sequences much faster than traditional methods. It's like having a detective that never sleeps or gets tired. This capacity dramatically speeds up the research process, enabling quicker identification of possible treatments or cures. Furthermore, AI and ML help in predicting disease outbreaks and potential drug interactions, which can be life-saving. These applications not only enhance the accuracy of research findings but also drive innovation by pushing the boundaries of what's possible in healthcare. With AI and ML, The future of biomedical research looks more promising than ever, bringing anticipation and excitement to both researchers and patients alike. These trends in personalized medicine and AI applications are reshaping the landscape of biomedical research design. By focusing on individual needs and harnessing technology's power, research in healthcare is taking significant strides toward a future where treatments are more effective and efficient. For students interested in this field, these trends highlight exciting directions to explore and contribute to, offering the promise of a better healthcare system for everyone.